All right.
Wow, that was brilliant. Burgundy, unbelievable. All righty. Here we go. 3069. Which is the side, if we know this side right here, if we know the shorter side is always opposite the shorter side, what do we know about the longer leg? If we know the shorter leg, what's the longer leg? What's the rule?
Oh,
It's radical 3 times the shorter leg. Yes?
yes, sir.
Who remembers what the hypotenuse is? Now give me your answer, Joe.
Times 2.
Yeah, the hypotenuse in a 30, 60, 90 is 2 times whatever the shortest leg is. So if you know the shorter leg, you know the other 2 legs. All right, does that make sense? Yes or no?
Yes.
All righty. Comprending? I can't believe I forgot to hit the button. All right, so here we go. Let's look at our picture, right? Let's give you a little sample, right? We have a little problem here. Let's see what the picture says. So we're going to make this 30, which makes this 60. So sometimes you got to make sure, it doesn't matter what the picture looks like, just make sure you know what you're looking at. So if I told you this was 5, what do you know about the longer leg? What do you know about the longer leg?
It's 5 radical 3.
5 radical 3. What do you know about the hypotenuse?
It's 10. Yeah.
It's 2 times the shortest leg, right? Does that make sense?
Yes, sir.
All right. So like if you took these numbers and put them into the Pythagorean theorem, do you think it would work? Do you think it would work? Of course it would work. Why?
Triggery.
Yeah.
I have to leave for the meeting now.
Yeah,
If
go ahead.
that's okay.
Yeah,
I'll
go
just when do you think you'll have the video up?
about 25 minutes after this class is over.
Okay. All right. Thank you.
Me too. I gotta leave as well.
Appreciate it.
All right. So if I took these 3 numbers and put them into the Pythagorean theorem, would it work out?
Yes,
Yes.
Of course it would. Why?
because it's the
Why?
right triangle.
Because it's the right triangle. All righty? All righty. What's the problem? What's the problem with the Pythagorean theorem?
It only works with right triangles.
Not only does it only work with right triangles, what do you have to know?
All the sides, or
You
two
have to
sides.
know 2 of the 3 sides. So what happens if you don't know 2 of the 3 sides? What can't you use?
Pythagorean.
You can't use the Pythagorean theorem. So what else can we use?
Sine, cosine, tangent.
Trig ratios. Very good. Sine, cosine, and tangent. So angles have trig ratios. So we talk about the sine of an angle. We talk about the cosine of an angle. We talk about the tangent of an angle. And we use these trig ratios to help us solve right triangles right now when we can't use the Pythagorean theorem. SOHCAHTOA, right? Sine, opposite over the hypotenuse. Cosine, adjacent over the hypotenuse. Tangent, opposite over the adjacent, right? So here's what we got. I've got a picture that looks like this. I know it's a right triangle. And they tell me that angle A is 73 degrees. Okay? And they tell me the hypotenuse is 6. Now, if I said to you, tell me the rest of that triangle, what's the easiest number to find?
The other angle.
Yeah. Well, this and this is what? 163, right?
Oh,
Yes, sir.
90 and
I think
73.
it's 17.
163. Hello? Hello? What's this?
Yeah.
17.
17, right? Has to be, why? 3 angles of a triangle add up to?
180.
180.
What else could you do? The 2 angles of a right triangle, the 2 acute angles of a right triangle add up to 90. So now I can figure out any of the other side. Which one? Let's figure out side B first. All right? So what do you want to use? What can we use? Can I use the sine?
No.
Oh,
Can I use the sine?
No. Wait,
Yes. You can.
I can use the sine of 17, right? What's the sine?
Yeah.
The opposite over the hypotenuse. So the sine of 17 has to be equal to x over 6. Has to, right? Yes?
Yes.
And then that's really a fraction, right? 6 times the sine of 17 equals x. And then if you do that number, what should you get?
Oh.
1.75, baby? Do the numbers. 6 times the sine of 17. What do you get?
1.75.
1.75. Very good. Now, what could you have done? What if I use this angle? What's the over the hypotenuse?
Use cosine.
I can use the sine of 17 opposite over the hypotenuse, or I could use what? The cosine of
Cosine.
73.
70.
Over that. What do you think you get? What do you think?
Same answer.
You got to get the same answer, right? Does that make sense? Yes, no, maybe? How would I find this number right here? A. Well, I could use what? The sine of 73 opposite over the hypotenuse. What else can I do? Cosine of 17 over the hypotenuse. Yes?
Yes,
What
sir.
else could I do? Tangent of 17 opposite over the adjacent. So it just gives you more and more things that you're capable of doing in order to find the answer you're looking for. Does that make sense?
Yes, sir.
All right. Everybody following that? You want to do another one of those, or are you good with that? Hello?
Those are the hard ones. Do one of those again, please.
Those are the hard ones? Oh my God. All righty, let's do another one. All right. Just remember, there's different things you can do. Remember, always remember this, fellas. When you know 2 angles of a triangle, you actually know the 3rd angle as well. Okay? Don't ever forget that. All right. So here's my picture. A, B, C, right? And then my given is that this is 15 degrees. All right. And my other given is that this is 16. So now I have 3 things that I have to find. I have to find angle B, I have to find side B, and I have to find side C. Everybody agree with that? Everybody agree with that?
Yes, sir.
All right, good. So, well, first thing I'm going to do is find angle B. That's kind of easy, right? What does 15 and angle B have to add up to? This is 90.
90.
What do these two have to add up to? 90.
90.
So what's 90 minus 15?
75.
75 degrees. So there you go. 75 degrees. All right, then. Which one do you want to find first, B or C? It's up to you guys. Do you want to find side B or find side C? Hello? Let's find B.
Yeah.
How's that for you? All righty. What are we going to use? What do you think the easiest one to be using is? If I use 75, I'm going to go opposite over adjacent. I can't do this one. I can't. How come I can't do the sine? How come I can't do the sine?
You don't have the
Because I have
hypotenuse.
2 unknowns, right? If I did the sine of 75, right, what would it be? B over C. What's the problem with that?
Don't know either.
I don't know either one. So I'm going to use algebra. 1 unknown. So I'm going to use 75. What am I going to use? Opposite over
Adjacent.
adjacent. What is that? What is that? Opposite over adjacent.
Tangent.
Tangent, right? You guys were told this, right? SOHCAHTOA?
Yes, sir.
All right, good. So remember it. All right? So what do I got? So the tangent of 75 has to be equal to the opposite, b over adjacent, 16. How do I get b by itself?
Cross multiply.
Yeah. So b equals 16 times the tangent of 75. And then that's just a calculator problem, right? Yes?
Yes.
Yes,
All
sir.
right. So what do we get?
59.7.
59.7. Very good. All right. Now, all I got to do is find C. Now what am I going to do? I could use 15 or 75. Use 15. Go ahead. What do you got? Well, use 75. Opposite over the hypotenuse. What is that?
Sine.
All right, so I can use that, or I can use adjacent over the hypotenuse. It's really not that big a deal. You can use either one, right? Cosine of 75 equals the adjacent over the hypotenuse. Now I got two steps, right? All right, C equals 16. I did two steps there by the same time, right? Does that make sense? What's this work out to? What's that work out to?
You're too low again, Coach.
What's that work out to?
61.8.
Yeah, there you go. All righty. Is that working? All righty. So don't ever forget, trig ratios are great. Trig ratios are great to use, right? When we have a right triangle, but we can't use, we're going to do one of two things. We're going to try to find the side, but we don't have two sides, or we're going to try to find the measure of an angle. Does everybody understand that?
Yes, sir.
All righty. So now we're going to do the same thing, but now instead of trying to find a side, we're going to try to find an angle, okay? So we know since we're going to try to find an angle, what are we going to be using? We're going to try to find an angle. We're going to use the inverse. So here's my picture, right? You guys jotting these pictures down?
Yes, sir.
Yes, sir.
I want to know what angle A is, okay? So since I know I have a right triangle, and they were nice enough to give me two sides. All right? I'm trying to find an angle. I'm not trying to find a side, so the Pythagorean theorem doesn't do me any good, right? So I'm going to use a trig ratio. Well, what two sides did they give me? Opposite over adjacent. What's the opposite over the adjacent? What's the opposite over the adjacent?
It's tangent.
Tangent. So the tangent of angle X has to be equal to 27 over 38. All right? Comprende? Now, if you do that, right, if you do 27 over 38, that means what? 27 divided by 38, you get what? 0.711. But I don't want to know the tangent of X. I want to know the value of X. So what do? I inverse it. I'll take the inverse tangent of 0.711, plug that into the calculator, and it gives me how many degrees? How many degrees does it give me?
Oh,
You guys using your calculator properly? How many you guys?
35.41.
35.
Do you guys get 35?
Yes, sir.
All right. Comprende? Let's take the same type of picture, but let's give you different values and different knowns. All right? So we're going to do the same thing. Remember, it's still a right triangle. We'll talk about a right triangle. And this time, I want you to tell me what angle XA is, right? So once again, but this time I'm going to give you these two sides. All right? So based on what they've given me, what trig ratio do we want to use? Based on what they've given me.
Sine.
Sine, right? What did they give me? Ready? They give me the opposite. They give me the opposite over, not the adjacent, it is adjacent, but it's also the hypotenuse, right? Yes?
Yes, sir.
So that's the sine. So the sine of x has to be equal to the opposite over the hypotenuse. Right? And if I put that into my calculator, I get the sine of x equals what? What's 40 divided by 42? Hello?
0.952.
0.952. So now I'm looking for I'm inversing the inverse sine of 0.952. That will tell me what the measure of the angle x is. And what do we got?
72.
72 degrees. Does that make sense to you guys?
Yes, sir.
Yes, sir.
All right, we got about 9 minutes left. I'm almost about halfway through your test. So we should be in pretty good shape here. All right, now, we know that we were given the Pythagorean theorem, and we can use the Pythagorean theorem to find the missing side of a right triangle, provided we know what? 2 other sides, right? But sometimes we don't know 2 other sides. We only know like a side and a couple of angles or something like that. Well, we know 2 sides. So what we do, or we don't have a right triangle. So what do? We use trig ratios. But sometimes we don't even have a right triangle. And this is what your homework is on. The law of sines, okay? And the law of sines we use to help us find measures and angles when we don't have a right triangle, okay? If we don't have a right triangle, we can't use certain things, but we can use the law of sines, provided we know one angle and the side opposite that angle, okay? Provided we know one angle and the side opposite. So if I have a triangle, right? A, B, C. And triangle ABC is not a right triangle, okay? I tell you the angle of A is 51 degrees. I tell you the angle B is 86 degrees. And then I tell you that side A is 38. Does that make sense? You guys get that down?
Yes.
All right, now, we obviously know it's not a right triangle, because if I put 90 there, that's way more than, right? So the first thing is easy. What's the measure of that angle? Well, if they tell you 2 angles, what else do you know?
The next angle.
Yeah, because they all have to add up to what?
180.
Yeah, they have to add up to 180. 51, 86, 43. 180 degrees. All right. Now, I can use the law of sines here. Why? Because what do I know? I know
Sides.
an angle and the side opposite the angle. See, I know this angle, but I don't know this side. I know this angle, but I don't know this side. But I do know this angle and this side. Does that make sense? So, what ratio can I set up? Angle, the sine of angle A over A has to be equal to, let's find C. Right? What would I write?
Sine of 43.
Sine of 43 over C.
C.
What else can I write? Hello?
Sine of 86. over
Sine
B.
of 86 over B. Now, and if you remember what Coach Pombalski did, right? There's your first problem. And where's your second problem? Where's your second problem? You're going to take this and put it with that, right? Does that make sense? So let's go find B. Let's go find B first. All right? So I know the sine of 51 over 38 has to be equal to the sine of 86 over B. Does that make sense to you guys?
Yes, sir.
All righty, what do you got? What do you do here? An equation between two ratios. All right? B times the sine of 51 has to be equal to what? 38 times the sine of 86. How do you get B by itself?
Divided by the sine of 51.
Divide both sides by this, and don't change those numbers yet, right? Just leave them in your calculator, right? Just make sure you put the parentheses around, and then you end up with B being 38 times the sine of 86 over the sine of 51. What do you get there? What do you get?
48.7.
48.8, yep, very good. Very good. Does everybody understand that?
Yes.
Not too bad, right? Now, how would we find C? Well, we just use the law of sines. So what are we gonna write? The sine of 51 over 38, right? The sine of 51 over 38 has to be equal to the sine of 43 over C. All right, and then what do we do? What do we do?
Divide both sides by the sin of, or the sine of 51.
All right. And then we divide both sides by the sine of 51, right? And what do we end up with? C equals? What do you got? Everybody get a number here?
33.
Not sure what it is. I didn't do it myself. Oh, so I hope you're right. All righty. So that's the law of sines. Anybody have any glaring problems right now? Hello? We all good?
Yes, sir.
Sir.
All righty. Hey, you guys know how to simplify radicals and stuff, right?
Yeah.
Sort of.
So if I give you a right triangle, and instead of giving you nice whole numbers, I give you radicals, you'd be able to tell me the missing side, right? Hello? Hello? Are you still there? We still got a couple minutes.
Yes.
All right, so for example, if I tell you you have a right triangle, and one of the legs is 2 radical 6, and the other leg is 4 radical 30, right? Would you be able to tell me what the hypotenuse is? Well, if it's a right triangle, what do you know? If it's a right triangle, what do you know, fellas?
A squared plus B squared equals C squared.
Yeah, we know this. So I'm looking for C. So here's what I do know. I know that whatever C is squared has to be equal to 2 radical 6 squared plus 4 radical 30 squared. Does that make sense?
Yes, sir.
So what's 2 radical 6 squared equal? 24. How do I do that? How does 2 radical 6 squared equal 24? What's 2 radical 6 times 2 radical 6? What's the rule for multiplying radicals? Outside with outside, under with under. What's 2 times 2?
4.
4. 6 times 6.
36.
What's the square root of 36?
6.
What's 6 times 4? 4.
24.
4. Plus, hey, what's 4 radical 30 times 4 radical 30. All right? Outside with outside, under with under. 4 times 4, 16. Radical 30 times radical 30,
30.
30. What's 16 times 30? 480. Right? That makes sense? So c squared equals 500. Hello?
Yes.
504, right?
Yes.
All right, so what's c?
The square root of 504.
All righty. Square root of 504, right?
Yes.
How do we figure that out?
Calculators.
Calculators. No. If I say exact, what if I said exact? Well, if I said estimated, you could just put that into your calculator. What if I said exact?
22.44.
No, that's not exact.
You have to find a perfect square that goes in
You have
different
to-
columns.
What? Factorization, right? All righty, we'll make that your homework for you. We'll make it your homework. Tell me that. Tell me what that is, simplified in radical form. All right? That's about. All right, so fellas, I've done 3/4. I've gone through 3/4 of your tests that you're going to have on Wednesday. All right? Now you're going to take it Wednesday, right? But it's not going to be due till Friday evening. Is that understood?
Yes, sir.
All right.
Sure.
So I have office hours, right? If you have any questions from 2 to 2:30 today, right? And then also tomorrow. And then Wednesday we'll have class again. I'll go through what else you need to know for your tests on Friday. But I've done 7 of your 11. I've gone through seven out of the 11 questions. Some of them are multiple questions, right? Does that make sense?
Yes.
Sure.
Does anybody not understand something we've done today?
No, sir.
Go ahead. Go ahead.
What about the when you have to find a angle with like law of sines?
What do you have to find an angle with the law?
Yeah, when you find like it was like an inverse or that I didn't see that.
Oh, well, yeah. So like that was with trig ratios, right? So the unknown is an angle and not a side, right? Who didn't see that? Who was talking there? Who was talking there? Hello? Who
That
was?
was me,
Who?
Matthew Gasparini.
Hey, Gasparini. All right. So you need to know how to use the inverse to find an angle.
Like on one of the like on one of those homework problems, it said you had to, instead of finding the side with the law of sines, you had to find a an angle instead. Like not by using.
Give me the homework. Give me the homework problem. Do you know the homework problem?
It was number 4 on 107, on page 107.
All right. So number 4. So it looks like this. Ready? Number 4 looks like this. Just make sure I'm doing the right problem. Okay.
It's all right.
A, C, B. Yes.
Yes, sir.
And then they tell you this is 73 degrees. What else did they tell you? This X.
B is X, yes.
This is 17. And this is 8. Right?
Sir.
All right. So it says the law of sines. Right? So it's not a trig ratio. All right, we can't use trig ratios because this is not a right triangle, right? All right, now, here's what we know. I can figure out what x is by using the law of sines, because here's what I do know. I have an angle and the side opposite the angle. So here's what I know. The sine of 73 degrees over 17 has to be equal to the sine of x over 8. Matthew, that makes sense?
Yes, sir.
That makes sense? All righty. So now what do I got? I got an equation between 2 ratios. How do I solve that?
Cross multiply.
Cross multiply.
So I got 17 times the sine of x has to be equal to 8 times the sine of 73. Make sense, Matt?
Yes, sir.
All righty, so I gotta isolate x, right? So I get rid of that coefficient. And I end up with the sine of x equals that number. All right, does that make sense? Let me move it over here a little bit. Matt, you following?
Sure.
All righty, so if I put those numbers in, right? If I stick these numbers, into my calculator, what do you get? Put them into your calculator. Tell me what you get.
.45.
Beautiful. Very good. Now, that doesn't tell me what x is. That tells me what the sine of x is. So if I want to know what the measure of angle x is, what do? I inverse it. So I take the inverse sine of 0.450, and that equals x. Does that make sense?
Yes, sir.
And then you just plug that into your calculator, and what do you get?
26.75 or 74. Yeah.
Does that make sense, Matt?
Yes, sir.
All right, so you know, hey fellas, you'll know you're going to use the inverse. You know you're going to use the inverse when you're looking for an angle measure, okay? Because,
Yes, sir.
does that make sense? When you're looking for a length of a side, you're just going to use the regular trig ratio, right? The regular ratios, right? But you're going to use the inverse when you're looking for an angle measure, okay?
All right.
Anybody else?
Yep. Thank you.
Anybody else have any problems? Okay, so we're gonna upload the copy of the test later on today, all right? And you're gonna have it till Friday. You're gonna use your notes. You can use your notes, all right? But your homework, simplify Radical 504 for me, all right? But your homework is also to download and copy. You have a paper copy of that test when you come to class on Wednesday. Is that understood?
Yes, sir.
And go through your stuff, and if you have any questions, then you can ask me right before you start. I still got 1 or 2 things I want to go through just to make an angle of elevation, angle of depression, stuff like that, and then you'll be all set. Does that make sense?
Yes, sir.
Yes, sir.
All righty, I'm trying to do as good a job as Coach Bombalski did, but that's going to be kind of tough. All right?
All right.
Make sense?
Thank you, sir.
I
Thank
have
you.
office hours hey, this number for the rest of the year, I have office hours at 2. So if you have any questions, you can ask me, no bother. Is that
So
understood?
what happened to
Yes, sir.
Mr. Bumbolski?
He just has to take care of something else. That's all.
Ah.
There's nothing wrong with him. He's upstairs.
Ah.
All right. He's going to come down now and make sure we get this all uploaded.
All right.
Alrighty.
All right.
All right.
Thank you.
Yes, thanks.
All right. We'll see you guys tomorrow on Wednesday, right?
Have a good one. Thank you.
Have a nice day.
All right.
Yep.
Robbie, you're late. Robbie,
Hello, sir.
you're late.